So, welcome everybody, and thank you very much for joining today's session. My name is Mel, and in case you do have any questions along the way, do feel free to pop them over in the chat, and one of my technical specialists will be able to assist you. So, we will be covering a lot about how to improve your XRF analysis in terms of throughput, in terms of achieving that high level of precision and accuracy and repeatability. And we will be showing you how you can achieve all of that on our latest range of XRF solutions. And we are streaming to you live from Perth, Australia, in our applications laboratory. So let me introduce my colleague that you see online, and you see his video feed right now. His name is Hari Baska, and he is our laboratory manager, and also he takes care of all our what you call process and automation solutions. So that's really useful in case you're looking at high throughput environments. And Harry has a lot of experience working with mining companies, and he is joined by my colleague Dale. Dale is our application chemist, and he's also based in Perth. And he has a lot of experience also with mining, and himself also having worked with in a service laboratory before. So in case you do have questions along the way, these are experts who can help you and advise you, whether it's coming in from, reference standards, technologies to use, or even understanding about, how you can achieve other useful, and also accurate analysis with XRF. So yes, Harry, now you have the controls, and go ahead to share more information with all of us now.
Sure, thanks, Mel. So let me start with sharing my screen, and then okay. Let me go. Are you able to see my screen?
Yes, we are.
Full screen? Yeah.
Yes, full screen.
Perfect. All right. Good morning, everyone. So yeah, we have had quite a bit of introductions and touched upon what we're going to do today. So I'll now get straight on to what we will cover in today's session, which I'll be doing first, followed by my colleague Dale, who will touch on the benchtop system. So we're going to look at the Zetium floorstanding XRF system today. What are the features and capabilities, and a bit of live demo. I'll start off with who we are and what sort of company we are and what solutions we offer. Then we'll look at the features of the Zetium. I'll also touch on the Roxy calibration package, which I mentioned before. And I've also got some analysis report on nickel ores that was done on the Zetium, and we'll look at the performance figures. And then we will move on to showing you a video of the live demo. Okay.
Harry, could you speak a little bit slower, just for our audience? Yeah. Thank you very much, Harry.
Sure, not a problem. Yeah, sorry, I do have a little bit of a bad throat, so I may not be quite audible. Yeah, if you're not able to hear, just let me know. So Malvern Panalytical, as a complete solution provider, what are the various technologies that we deal with? Already we have been introduced to X-ray spectrometry, which is elemental analysis, chemistry. Now it's not only X-rays, we are also into neutron analysis technology, and these are those online systems which run across the belt doing elemental chemistry. Now we are in collaboration with a company called Zetium, who are based in France, and we market the online technology. We are also into mineralogy using X-ray diffraction as well as near infrared. So complete solutions based on diffraction and infrared with a whole range of products and solutions, combined with complete lab automation. That is also something which we are able to offer to our customers. And to back up all these instrument solutions, we have a complete team of expertise across the world as well as within this region. Our specialists are able to provide solutions for all our technologies to bring to the table for the customers the analysis that they need. I think Mel also mentioned before that we have analytical services, which we have in our UK facility in Nottingham, where we can develop calibration standards, certify samples, and so on. And every country has a very strong service organization. We also have a complete range of particle size analysis, which is from our Malvern particle size range. I don't know, maybe some of you already have particle size instruments, and if it's Malvern, then yeah, it's from us. And a complete range of sample preparation, which is mainly fusion from the clay product range. So that sort of gives a complete analytical picture where we'll be able to support the customers with a holistic solution. About a holistic solution, this is something which I also wanted to highlight, that we can offer it as a, if you're looking at a high throughput facility with some level of automation, then we can also integrate all these instruments to run in a completely robotic automation facility. Now, it can be sample prep equipment from other third parties or even analytical equipment from other third parties combined with our own instrument running in a robotic environment.
Hari, thank you so much for sharing. I think Hatoyo would like to translate.
Yep.
Yeah, thanks Mel and Hari. Hari, can you show? Yeah, okay, thanks. Bapak Ibu sekalian, sebelum kita nanti menyaksikan live demo untuk alat yang pertama Zetium, ini dari live Malvern Panalytical Australia. Tadi Hari Baskar menyebutkan mengenai history dan juga gambaran dari company profile Malvern Panalytical. Jadi Malvern Panalytical di sini gabungan dari beberapa company yang merger menjadi satu. Yang dulunya Bapak Ibu sekalian pernah paham dengan Panalytical. Kemudian ada juga perusahaan Clays di sini untuk sampel preparasi, dan Malvern yang lokasinya di UK untuk particle size analyzer. Kemudian di Malvern Panalytical Group kami juga ada ASD untuk near infrared. Dan ada pula untuk online analyzer yang ditempatkan alat di belt conveyor ya, dengan perusahaan Soden di Prancis. Nah, untuk aplikasinya memang sangat bervariasi. Jadi menyebar dari sampel prep, kita juga ada fusion preparasi, kemudian ada XRF juga, ada XRD, dan di Malvern Panalytical kami juga ada analytical service di Nottingham, UK. Jadi ini divisi yang membantu mengenai sistem calibration pembuatan standar sampel. Jadi misalnya ada Bapak sekalian mengalami kesulitan dalam pembuatan standar sampel karena misalnya matriknya sangat susah atau bervariasi, di Malvern Panalytical bisa menyediakan standar kalibrasi atau standar sampelnya. Dan dari semua unit Panalytical, Soden, Clays, Malvern, kita merger menjadi Malvern Panalytical. Ini adalah sebuah perusahaan yang di bawah naungan Spectris PLC. Dan next slide, Hari, please. Di Panalytical, kami selain standalone XRF XRD, sebetulnya di beberapa customer seperti di semen, kemudian di tambang metal dan beberapa industri bisa digabungkan dengan online atau automation preparasi. Jadi preparasi dengan sistem robotik. Nah, itu bisa untuk meningkatkan dari sisi kecepatan dan juga dari sisi throughput untuk analisis di perusahaan Bapak Ibu sekalian. Okay, thanks. Yeah.
All right, so let me just continue. So we will now start looking at the Zetium WDXRF. How do we achieve robustness, speed, sensitivity, flexibility in this system, and how does it help the customers in achieving the accuracy, precision, and throughput? This is also combined with a very innovative support solution, which I will touch upon a bit later. So the Zetium WDXRF is, the technology itself is not very new in the market. It has been built on the last 6 years of experience, and some of you may be users of our older Axios range of XRFs. So it is built on the functionalities and performance of that, but in a much better and a much faster, smoother way, with new electronics and new safety setups. So these are some general overview of what the Zetium is built on. And in terms of what we are offering to the customers, the Zetium comes in a few different variants, mainly separated by the wattage of the instrument. So we do have a 1 kilowatt system, a slightly lower powered system, depending on the throughput that you would like to achieve on a daily basis. And we also have a slightly higher powered range, starting from say 2.4, 3, or 4 kilowatt systems. Given a typical example here of a 14-element analytical suite, and if you're doing something like that, it could be say nickel ores, or it could be bauxite, it could be cement, whatever it is. Typically, on a 1 kilowatt system, you are able to do at least 200 to 300 samples per day in a 24-hour period. If you go for the higher wattage systems, then your throughput increases up to 500. Now, this is if you're doing it by press powder analysis, because the sensitivity is higher, and it also takes into account some of the instrument and operator overhead required. Let me move on to the next slide, unless Hani, Sakayo, you want to translate, or I can move.
Oke. Bapak sekalian, seperti kita ketahui, unit pertama yaitu Zetium. Ini adalah tipe WDXRF. Jadi tipe ini memiliki range power dari 1 kW, 2,4, 3, dan 4 kW. Tentu saja dengan perbedaan power ini akan mempengaruhi kecepatan analisis. Nah, kalau yang 1 kW itu bisa sampai sekitar 300 sampel per hari, sementara yang 2,4 sampai 4 kW bisa sampai 500 sampel per hari. Nah, tentu saja ini membutuhkan tips dan triks yang nanti kita akan bahas untuk di sesi kali ini. Okay, go ahead, Hari.
Okay, so one of the most important things is the X-ray source, or the X-ray tube. And this is something quite interesting and unique that we have in our X-ray tube, what we call as the Zeta technology. Now, generally, X-ray tubes will have a loss of intensity over a period of time. So because it is consuming certain amount of energy, the way it works, conventional X-ray tubes have a drop in intensity over several thousands of hours, as you can see like this. The Zeta technology tube that we use uses a special cathode which does not oxidize so easily, which means that the loss in intensity is not so much. Now, this example here shows the measurement done over a long period of time, probably about 3 months or so. And you can actually see the loss in intensity is quite low, even for the low atomic number elements like calcium, and even the heavier atomic number elements like nickel. Now, what does this mean for customers? It reduces the effort of doing recalibration on your system, because the intensities are not dropping, which means your sensitivities and precision are not going to change over a long period of time. So this is quite an important aspect as far as WDXRFs are concerned, that the tube technology is at par. Now, this is possible for us because we manufacture our own X-ray tubes, unlike any other manufacturer. So we have a full control of the quality of our X-ray tubes. The other question that normally comes up when we discuss about different XRFs instrument, which customers also ponder upon, is whether the tube up geometry or the tube down geometry is better. Because there are manufacturers who do have systems where the tube is above the sample, and the argument there is normally that if you're doing press powders and if there is any sample spillage, then it doesn't affect the tube. Yeah, that is true, but there are several other advantages to the tube down geometry. One of the important ones being that when the samples are placed inside the system, it is absolutely necessary that the sample surface and the distance from the tube is quite critical. Now, this schematic here shows the intensity of X-ray is proportional to the inverse of the distance. That means if this distance between the sample and the tube is even changing by a few microns, then an inverse of that would be a large change in the intensity. So in simple terms, if the sample is not sitting properly, if it's slightly displaced, then you are going to actually see a big difference in your results. Now, with a tube down geometry, the samples are placed by gravity. That means you don't have to put the samples in a sample holder, lock it with a spring, and then mount it upside down, which is normally what your tube up geometries are. So this example here shows the tube up with the samples that are placed in a cup and they are locked in place using a spring. And what normally you have to also do is place the cup on a jig to ensure that the height of the sample is within the limit, and then you have to put it into the XRF. Now, this is normally the case for every sample. What it also means is that for every sample, you also need individual cups. So if you're doing 100 samples in a day, that means you have to have 100 cups or 100 sample holders. There are other designs of tube up geometries where you can put samples directly without cups. However, the way the samples are loaded below the tube, you will find that there is a plunger mechanism which has to push the sample up as close as possible to the tube. So you're already introducing a movement, and if that plunger, which is based on pneumatics, if it is does not pushing it up properly, again you're going to have the same issue, that the distance between the sample and the tube is going to change, and you're going to see a problem in your results. Whereas in the tube up-down geometry, the samples are always constant. It is placed by gravity, and you don't have a chance of any displacement error. So this is a really a big important aspect as far as the tube down geometry goes. Not only this, if you're doing press powders, a good sample preparation has no alternate, and a good sample prep would take care of any sample spillage in your instrument. Now, there are also other things that we have in our Zetium system. In case if there is sample spillage, how do we handle that? I'll be talking in the next slide. So before we go into looking at that aspect, the other aspect that's quite important is also how precisely the samples are loaded into the XRF. Now, the technique that we use is called as two-position loading. So here you can see this is a schematic of how the system looks inside. There are two positions, a loading position, and there is a measuring position. So you have the X-ray tube below the measuring position, and the samples are loaded at the loading position. And this is isolated from the measuring position. So what this means is that the samples are loaded separately. There is what's called as a dust collection device, which I will touch in the next slide, which simply sucks all the dust in the loading position. And then the sample is moved to the measuring position. So let me see if I can run this short video, which shows the technique. The samples are loaded, as you can see. The cup is placed, and then it rotates, moves it to the measuring position, and the measurements are taking place while the other sample is being unloaded. The other important aspect here is that because of this technique, the X-ray optics is completely isolated. So the X-rays can be continuously running without having to turn it off. Now, unlike there are other systems available in the market where these two-position turrets are not designed. So the samples are directly loaded on top of the X-ray tube. Now, you can imagine that if the samples are being loaded directly on the tube, you have to open the sample cup, which means you're exposing X-rays outside. And so because of this reason, they switch off the X-rays for every sample. So this is quite an important aspect, because if you're going to switch off the X-rays for every sample, you are introducing thermal shock, which also reduces the life of your X-ray tube. So imagine if you're doing 100 samples a day and you're switching off the X-rays 100 times, that means you are introducing thermal shock, which reduces the long-term longevity of your X-ray tube. Now, in case of the Zetium, even with the Axios system, this is not the case because of this separate sample loading technique. On to the next slide. This is the dust removal technique that I mentioned before. So what we do here is when the samples are loaded, so let me just go back to this slide. So when the samples are loaded in the cup, in this loading area, the dust removal device is located just below the sample loading area. So let me probably show this on this video, which might help understand. So the sample loading is done above, and the dust collection device is located there with a tube which goes and connects to the vacuum pump. So when the samples are loaded, as you saw, the cap closes and that chamber is fully connected to the vacuum chamber and collects all the dust in a small container, which looks like this. And then you can remove that dust or broken samples even while the XRF is running. You don't have to shut down the XRF. You can simply take it out, throw the dust and put it back in. Now, we don't have to do this every day because the container is good enough to collect dust. So even if it is done every service, that should be fine. So this absolutely takes care of any sample dust going into the optics and falling on the X-ray tube. So this is something that would be very useful if you are doing press powders regularly, and takes care of the issue of having any sample dust falling on the system. Arisan, do you want to translate, or can I move on?
Yes, Harry, please. I want to translate some information important. Can you show the previous slide?
The next slide.
Ya. Bapak sekalian, X-ray tube yang dipakai di Zetium ini menggunakan SSD Max dan memiliki lifetime yang cukup panjang. Sebenarnya bergantung juga dari sisi perawatan dan juga maintenance dari Bapak sekalian. Ada dari beberapa customer kita itu umurnya sudah hampir 13 tahun, 12 tahun, 13 tahun itu baru mulai turun. Jadi misalnya GPT Inalum itu juga sangat bagus lifetime-nya. Kemudian tadi disebutkan geometri oleh Mr. Hari Baskar bahwa X-ray tube posisinya di bawah sampel. Kenapa di bawah sampel? Jadi yang pertama bahwa XRF itu bisa mengakomodir semua jenis sampel, baik sampel padat, sampel powder, dan juga sampel liquid. Yang pertama. Kemudian yang kedua, dengan sampel di atas X-ray tube atau tube-nya di bawah itu posisinya akan selalu stabil karena efek dari gravitasi. Ada pula beberapa tipe XRF di pasaran itu menggunakan tube-nya di atas. Memang dari sisi safety memang lebih bagus sekarang. Akan tetapi ada beberapa problem di sana. Yang pertama adalah adanya sampel spring. Jadi biasanya ada pair di situ yang mengakibatkan kondisi sampel bisa naik turun. Itu bisa berimbas kepada naik turunnya intensitas. Kemudian di Malvern Panalytical dalam hal ini Zetium itu memiliki yang disebut dengan continuous loading di situ chamber, di mana dilengkapi dengan small vacuum dan X-ray tube-nya selalu on. Tadi disebutkan biasanya kalau di service lab atau di tambang smelter sampelnya yang sangat banyak, misalnya mengakomodir ratusan sampel, bayangkan kalau setiap sampel kalau X-ray-nya harus selalu on off itu akan mengakibatkan pada sisi lifetime dan juga intensitas daripada X-ray tube itu sendiri. Nah, lalu bagaimana pertanyaannya kalau misalnya ada sampel yang tidak proper dari sisi sampel preparasinya? Nah, di Malvern Panalytical, di Zetium itu dilengkapi dengan dust collection device, dust removal. Nah, ini lokasinya di belakang. Jadi meskipun X-ray-nya nyala, ini masih bisa dibuka. Maksudnya tidak harus mematikan XRF-nya, tidak harus membongkar chamber, cukup membongkar di bagian belakang. Okay, Hari, enough.
Okay.
Yeah.
Thank you. Okay, so let's move on. Okay, the other interesting feature is that the samples, if you're placing a batch of samples, say 50 samples or 100 samples for a batch analysis, now you don't really have to have 100 cups for each sample. So what we call as this direct sample loading technique, where samples can be directly placed on the tray and you only need 2 cups to be placed, or even 1 cup to be placed in the front. And the sample changer head has a suction device in the middle. So it can go directly pick the sample using the suction device, place it into the cup, and then pick the cup using the grab and place it in for measurement. So samples can be of different sizes. It can be 40 millimeter samples, it can be 32 millimeter samples or larger. And there are different types of trays available for that. And you don't really need to have the whole sample changer filled with cups. Now, this is also an initial cost saving where you will not be needing to spend on buying a lot of sample cups. Now, during the live demo, I will show you how this technique works. The other aspect is that what we call as a continuous loading mode, which is an option which is available in the Zetium, where I had showed you previously that the samples are loaded on the loading area and then moved to the measuring area, measured in the measuring area. A second sample can be loaded in the loading area, and it can fit inside the vacuum, which can then stabilize itself and then move on for the next measurement. What this means is that you are stabilizing the next sample ready for the measurement, which means this improves your precision of your measurement, the reproducibility of your results. And this continuous loading can keep doing for every sample in that batch. And this is quite a unique technique, because this dual position sample loading is not usually available in some of the other well-known brands. As I mentioned before, different size samples can be handled using different types of trays. Now, this example here shows direct samples placed on the sample tray. You can also see a tray with cups. You can have different sample sizes. Here you can see these are liquid samples. So you have got liquid cups, so they look slightly different. So liquid cups can be loaded on specific liquid sample holders. And the liquid cups are basically plastic holders with a foil. You can fill the liquid and place them in. So you can mix and match different types of samples on the sample changer, and the system can automatically send whether it's a liquid or a solid sample. And also in the program, you would have set what sample sizes are. So a lot of intelligence is built into these type of setups. Now, if you are looking at a very large throughput, more than 100 samples to be run in a batch, we do have what's called as a high capacity sample bed, where you don't have trays, you just have a whole sample bed, and you can load up to 140 samples at the same time. If they are 40 millimeter samples, then they are about 140 samples. If they are smaller samples, 32 millimeters, you can even go higher than that. So again, these are aspects where sample throughput, batch analysis, flexibility and robustness, all these things are catered to the way the ZTM is designed for work. Okay, I might just let you translate this because the next slide I will touch on some of the special optics.
Oke, ya. Bapak sekalian, di Zetium ini dilengkapi dengan continuous loading untuk speed up analisis dan juga direct sample loading. Jadi dengan direct sample loading dan juga continuous loading ini bisa mempercepat analisis dan juga bisa mereduce dari sisi sample cup. Sebenarnya tidak butuh sample cup yang terlalu banyak karena sistemnya adalah direct loading. Nanti Mr. Hari Baskan akan menunjukkan bagaimana sistem direct loading itu bekerja. Kemudian di dalam sample changer di Zetium itu ada berbagai macam option. Next slide please. Jadi bisa dengan high capacity sample bed. Jadi kalau Bapak Ibu sekalian yang sampelnya sudah fix untuk di fuse bed semua, ini ada option bisa di atas 200 sampel untuk sekali running. Untuk layoutnya seperti yang Bapak Ibu sekalian lihat. Ada juga bisa pakai tray dan ada juga option tadi sampaikan untuk sampel liquid dan lain sebagainya. Jadi ada berbagai macam kemudahan yang bisa dipilih, baik itu sampel press, powder ataupun yang fuse bit. Okay, Harry.
All right. Okay, so these are something which are standard in our Zetium, right? All these features that I have told you, they're all coming standard in the Zetium. Absolutely useful and required for having the required robustness and sensitivity and so on. But we have more to offer, more special optics, detectors, and so on, which are quite unique to our system. Again, these are some things which normally not available or offered by other equivalent, let's say, brands available in the market. So let's see some examples here. I'm not going to go into the details of each feature here. If you are interested to know more about these, then we can of course have a one-to-one discussion through the sales channels, and you can evaluate these requirements. So one of the nice features that are available in the Zetium is what's called as the SumExpo technology, where we combine EDXRF into the Zetium. So you can actually see a schematic here. So the general WDXRF is this part. And then we also attach an EDXRF into the Zetium. So what this means is that you can now have two XRFs or two types of XRFs sitting in the same machine. There are different benefits and advantages. You can combine your complete analysis, split the elements between the ED and the WD, which means it improves your analytical speed because both are going to work parallelly. You can also use the ED as a backup for your WD. And you can also have results from both the ED and WD separately, which means it gives a bit more confidence from the results that you're getting. The ED also captures the complete sample spectra. So if you're even not analyzing any element, if the elements are present in the sample, the ED spectra automatically captures that. And you can go back and look at the spectra, find out if there is any unknown element sitting in the sample. We also have what's called as an integrated barcode reader. So this reduces manual error. So the integrated barcode reader sits on the sample changer head, and the samples can be put with a barcode sticker, and the operator does not have to enter sample IDs and application selections or anything like that. So all they need to do is just put the samples on the sample changer, start the measurement. The barcode reader will read the barcode, which has all the information, and then it will automatically start the analysis. So a certain level of robustness and automation comes into play. But we also have what are called as specific fixed hyperchannels. Now, these are very useful if you're doing very low atomic number elements like sodium or even fluorine, carbon, and elements like that, or even some of the heavier elements, where a dedicated fixed channel consisting of a crystal and detector sits parallelly in the optics area somewhere here and keeps running simultaneously when the WD is measuring other elements. So again, reduces the overall measurement time, increases the throughput as well as the sensitivity for that particular element that you're measuring on the fixed channel. We do have more to offer. As you can see, we have special detectors. there are two types of detectors: a sealed detector, which is called as the duplex mode detector, and a scintillation detector. So this is on top of the standard scintillation detector. Normally, the linear measurement range of standard scintillation detectors is about 1 million counts per second. That means if you're measuring high concentrate samples, the standard detectors could easily saturate. Yeah. Then you will have to reduce your settings in order to bring it within the detector electronics. With these special detectors, the analytical range is increased almost 3 times. So 3.5 million counts per second, which means that you can measure high concentrate samples and trace elements all in one calibration without compromising on any sensitivity. So this is an additional boost in terms of having a much robust calibration technique. We also have special analyzing crystals, synthetic crystals as an alternate for the standard LIF 200 crystals with a better sensitivity and resolution. There's a whole range of crystals that we can offer. So again, as I said, if you're more interested to learn about these, or if you would like to have these in your systems, you can always talk to the sales channels and they can help you out on that. So with this, I will move on to Smart Manager. You want to translate, Esan, at this point?
Yeah, just a few minutes. Okay.
Sorry, do you want me to go ahead?
Oke. Ya, Bapak Ibu sekalian, ada feature tambahan untuk di Zetium ini. Jadi Zetium bisa dilengkapi dengan tambahan detektor ID. Jadi bisa dinamakan EDWD kombinasi. Jadi ini bisa analisisnya bisa simultan sequential, bisa ditambahkan optional seperti itu. Ini sangat bagus untuk mengejar kecepatan sampel yang sampelnya juga sudah banyak. Kemudian ada juga option integrated barcode dengan sistem barcode. Ini sangat berguna untuk tracking sampel, jadi biar tidak ada kesalahan dan lain sebagainya. Di beberapa negara-negara yang sudah sampelnya banyak, perusahaan sudah banyak memakai sistem barcode ini. Kemudian Zetium itu adalah sequential WDXRF, namun bisa menjadi sequential dan simultan apabila tadi ditambahkan detektor ED dan atau bisa ditambahkan dengan channel, seperti halnya di unit yang besar yang lainnya. Next slide, please. Next slide, Harry. Ya, ada juga beberapa option tambahan seperti duplex detector dan juga special crystal. Jadi ada kristal yang jenis curve, ada yang flat. Jadi di Zetium itu bisa ditempatkan maksimal 4 detektor dan juga bisa ditambahkan maksimal sampai 8 kristal di goniometer. Belum termasuk ditambahkan lagi dengan fixed channel. Oke, Harry.
Right. Okay. Now, another interesting feature that now we have introduced with the Zetium is called as the Smart Manager. Now, what is this Smart Manager? So this is a piece of cloud-based software which can collect the status of the instrument. That means all the parameters in the instrument in a dynamic way and collect that information, store in a cloud database, and then be made available to the customer on a nice front-end software screen. So what are the information that you can look at? If you have multiple systems in multiple sites, then you can see the complete fleet in one screen. So you can go select your instrument, look at the status of the instrument. You can also look at the utilization of the instrument. That means how many samples are running on each instrument. So if you say have 2 or 3 instruments in the same lab, you can actually have a monitor on, is one instrument running more samples than the other? Is it being distributed properly? So it gives you a clear picture of the fleet utilization as well as the life cycle management of your instrument. It also gives you predictive maintenance schedule. That means all the parameters like your vacuum, your heat and gas, all the dynamic parameters they're all logged, and you can look at those logs as graphs, which gives you a clear picture of whether the instrument is running properly or is there an issue, and so on. What this also helps the service engineers to also remotely look at this data, prepare themselves for any service visit. So if there is a breakdown, they can log in, look at this data, prepare for the service, bring parts that are required, and so on. So this is a very nice cloud-based feature. Once it is set up, it is running in the background, and you can even look at this data on your iPhone or an Android phone. So if you're the plant manager and you want to instantly look at what's happening with your instrument on your phone, you can actually look at this kind of information. And if it is across, as I said, multiple systems, then all of that information is available at your palm. So this is the feature now. It's available on all the Zetium systems. It is a licensed feature, so we can actually make this available as a part of a service contract as well. I'm just going to move on to Roxy. Given the time, I think we just have to move. So let me introduce the Roxy certified reference materials. So what is Roxy? Now, normally when you're doing XRF analysis, you need to have calibration standards. You use them to calibrate, and then you're able to run routine samples. Now, the biggest challenge is how do you get calibration standards for your different applications? Now, if you're especially doing, if you're doing fuse beads, then you can buy certified reference materials, CRMs, which you can buy from different sources. If you're doing press powders, it becomes a bit challenging because you need to have standards which are similar to your routine samples. So the Roxy is a method which can actually help, whether it's fuse beads or whether it's press powders. So let's see what is actually the Roxy calibration set. So the Roxys are a set of synthetic calibration standards. So they are made of pure oxide in different combinations, and they are actually available as certified reference standards. You can buy these as CRMs, very similar to buying a bauxite CRM or a cement CRM or a nickel CRM. You can buy this whole set as a certified standard, which means it gives you full traceability that your results are based on a CRM-based calibration. What we will also be able to provide is the sample preparation methodology for preparing the Roxy, because they have to be prepared as fuse beads. And then if you're doing a fuse bead analysis, they can be used as a primary fuse bead calibration. Now, this also saves, it's quite cost effective in the sense you don't have to then go and buy traditional CRM for each type of material. So the same Roxy can be used for different types of material. It can also be extended in calibration range. We can extend the calibration range if you like. And the most important thing is that the Roxy can be used as a primary calibration to develop secondary press powder calibration samples. We'll see how this is possible. I'll explain the method. What does the Roxy basically come with? So the Roxy comes in two variants, a base and an extension. And this is the element range that is standard covered by the Roxy. And you can see that it covers anywhere from 0 to say 50 to 100% for each of these elements. So this is the highest calibration concentration for each element, as you can see. And as I mentioned before, the Roxy can be customized. We can extend the number of elements. If you need more elements, we can prepare those accordingly. And if you specify the calibration range, we can also prepare the standard according to that. The interesting bit is how do we use the Roxy to develop in-house calibration standards for press powders. So normally what you have to do is take your press powder samples. This can be your run of the plant samples collected over different time frames, grind them properly, homogenize the samples, and split them so that you make one set of fuse beads and one set of press powders. Now, on one side, what you also have to do is prepare the Roxys into fuse beads, set up a Roxy calibration, which is called as the primary calibration, run the routine samples, which are prepared as fuse beads on the Roxy. You will get the concentration value. Use those concentration value as secondary standard concentration values. And the press powders that you have prepared from that same sample, use them as secondary standards, prepare a press powder calibration. So now the press powder calibration is fully certified because they were prepared based on certificate values that came from Roxy, and the Roxy itself is a certified reference material. So you can now see the traceability of developing your own in-house press powder calibration method without having to say send samples to an external lab and getting them tested and so on. Now you can prepare your routine press powder samples and run it on your press powder calibration. Now we can provide the solution to prepare these Roxys as fuse beads, prepare your routine samples also as fuse beads, and help with setting up the Roxy calibration on your XRF. This means either you can buy a fuse bead instrument, a single position fuse bead instrument to prepare the beads, or if you don't want to do that, we can prepare the beads, set up the whole Roxy setup for you, and all you then need to do is just prepare the press powder method. So either way, the method works in preparing in-house standards for press powder calibration. I just ask you to translate now at this point, Sunny, because I'll now go to the part. You want to quickly do a translation?
Ya, oke Hari. Bagus sekalian. Salah satu modul untuk aplikasi yang ada di Zetium itu adalah paket Roxy. Sebetulnya masih ada beberapa paket yang lain. Kalau di industri semen ada Semoxy. Kemudian ada juga tambahan paket kalau misalnya ada beberapa riset dan juga perusahaan tambang yang menganalisis rare earth atau logam tanah jarang, kita juga ada menyediakan standar sampelnya juga. Nah, dalam hal ini Roxy dilengkapi dengan CRM Certified Standard dan dilengkapi dengan sertifikat dan juga datanya yang terintegrated dalam SuperQ software di Zetium. Nah, di Roxy ini bisa dianalisis rutinnya nanti dengan fuse bead ataupun pula dengan press pellet. Nah, ya next, ada beberapa elemen yang tercakup dalam Roxy ini. Namun hal demikian, kalau misalnya ada range yang mau diperluas dari misalnya agak kecil atau dinaikkan, itu bisa dimodify dengan tambahan standar sampel yang lain. Oke, Harry.
Alright, okay. Yeah. So I'll now quickly touch on an application work that we did here in our Perth lab on nickel ore samples that we received from Indonesia. So what we have done is we have done this on a 1 kilowatt based ZTM XRF just to show the performance on a typical nickel suite. So the samples are prepared as press powder. The samples were received as already pulverized below 70 micron size. Now this is quite important that samples are nicely pulverized below this, say at least below 70 microns. They were prepared as press pellets with 8 grams combined with 2 grams of binder, pressed at 15 tons. And we got some nice pellets. Used about 7 or 8 of these standards as secondary calibration standards. Now this is the calibration range. And it's a very short calibration range, as you can see. The analytical time was less than 90 seconds. So just 1.5 minutes on a 1 kilowatt system. And you can also see the calibration accuracy for each element, especially for nickel. You can see with a 1 to 4% range with a plus minus accuracy of 0.02 and a detection limit of 16 ppm. So even with 90 seconds measurement, you can get down to very low detection limits. I mean, you would not be measuring at these levels, but you can see that even with a 1 kilowatt system, the kind of detection limits you can achieve and the calibration accuracy that you can get from this. What we then did is ran 2 or 3 samples as routine samples to see how the performance looks. So this is just to show you the standards, the samples that were used as standards. So I won't go too much into the details of that. And also the hardware settings or the measurement conditions. Here you can clearly see that the kV and the milliamps are actually 1 kilowatt settings and the optics that was used. So very basic setup of a 1 kilowatt Zetium. And you can see how linear the calibration graphs are for press powder. So let's look at some results. So on the left-hand side table basically shows the accuracy and bias on two routine samples, SAP 1.9 and 2.17. So the XRF results are shown here. The certified or the nominal values are shown. And the relative difference, as you can see in both the cases, in this case, these two samples, the relative bias has been less than 5%. In fact, for nickel, you can see it is less than 2%. So generally, we are able to achieve a relative bias within 5%, 10%, depending on the calibration standards and the sample preparation. And for nickel, it is absolutely, it could be less than 1% if you like. Also look at the precision or the repeatability. So the same pellet was run 15 times to look at the instrument repeatability. And this is the average concentration. Again, the measurement is only 88 seconds per sample. And this is the standard deviation of the measurement. So you can see that nickel is 0.003, which is really, really good. Even for the low concentration elements like cobalt and so on, the precision is absolutely fantastic. So I think that was my last slide. You want to give a quick translation, and then we can move on to just having a quick look at the ZTM itself.
Ya, Hari. Oke, thanks. Bapak sekalian, ini Mr. Hari mencoba running sample untuk nickel ore, sampel dari Indonesia, menggunakan metode preparasi press pellet. Kemudian ini ada beberapa elemen dari ada sekitar 10. Namun hal demikian bergantung nanti dari kebutuhan Bapak Ibu sekalian. Misalnya sekarang ada beberapa tren SC sangat penting atau scandium penting, nah nanti bisa ditambahkan di situ. Kebetulan ini pakai yang simpel, yang standar. Jadi di sini bisa dilihat dari sisi presisi dan akurasi. Next slide please, Hari. Ya, ini kurva kalibrasi bagaimana settingnya, ada menggunakan sekitar 7 standar di situ. Oke, next slide, Ari. Ya, waktu analisisnya ini sekitar 88 second, berarti sekitar 1,5 menit. Untuk Zetium yang paling rendah ini yang 1 kilowatt. Tentu saja kalau yang lebih tinggi bisa lebih cepat lagi. Kemudian Bapak Ibu sekalian, di sini kita lihat dari standar deviasinya baik nikel maupun elemen yang lain mendapatkan hasil yang bisa dikatakan lumayan bagus dan acceptable. Dari sisi presisinya pun juga hasilnya juga sangat bagus. Jadi saya kira meskipun dengan 1 kilowatt bisa memenuhi kebutuhan dalam hal ini untuk sampel nikel. Okay.
All right. Okay.
Please go ahead for the live demo.
Yeah. So let me try to share my screen and switch on the video so that let me see. Okay. So you're able to see my video screen.
Hi, Harry. We can't see it. Oh, yes. I think it's loading now.
Yes, now we see the software.
Yeah, 1 second. So that's the software screen of the Zetium video. Yeah.
Yes.
Okay, perfect. So let's.
Audience,
Okay, so
if you do wish to have the video in full screen mode, what you need to do is to double click on the video that you see from Hari at this point in time. So just help to double click on that so that you can expand the image. All right, and it should be already in spotlight mode so that you can see it in full view. And I do see that we have some questions. Do feel free to type them over, and we will be getting to you during the Q&A. Thank you. All right, go ahead, Hari.
Okay, I just thought I'll give you a long shot of the Zetium instrument itself and then probably go get closer. Now you might see the cell of the instrument there already, and you can also see on the background behind the machine the required services like your peat and gas bottles, and probably on the side there, sitting next to the machine on the back, a little air compressor for the pneumatics operation. So let me now go closer. Just have a look at the sample changer area. Just tell me if it's clear. Okay. Right. So here you can see, so the front portion here basically has the cups which can be used for loading the samples. And on this side where the sample trays are present, there are different types of sample trays. Now, over here I've got a sample tray with pressed powder samples, 40 millimeter pressed powder samples, direct samples sitting on the tray, and another tray with a smaller size. So if you have 32 millimeter samples, then these trays can be used and they can be mixed and matched. There's another tray over here, which has got fuse beads, which again can be mixed and matched. And a fourth tray, which you see at the far end, where direct cups are loaded. So these are cup trays where samples can be put into these cups and they can be used. But the interesting thing is that you don't have to have cup trays throughout, but you can have direct samples. And I'll show you how the samples are loaded using the sample changer head. On the far end over here, if you see, you're able to see that. There's also a special tray if you want to place monitor samples, QC samples, and so on. So you can use those trays. And there are trays behind this cap mechanism as well. There are trays behind this as well. Okay. So let's try to quickly run a sample. So I'm going to close this lid because this is a mechanical safety. So the lid usually needs to be closed in order to try. So you can watch the video as well as see the software screen. Then I can quickly run sample. So to just prepare and run a sample, you can go click on one of the positions, select the program, select the measurement type, just put your sample ID. Now this is where I said if you had a barcode reader, you don't have to do all this. The barcode will have all that information, and the sample changer head, actually in the video, you can actually see on the sample changer head, you can see there's a red colored black and red device. That is the actual barcode reader itself. Okay, so I will put the sample ID and add that to the list. So now I've got a sample assembled, and all I need to do is go and measure. And please watch the video. The sample changer will basically pick up the sample. Now you can see that the sample is being picked up by the suction head, and it is being placed in the cup. And now the cup is placed in the loading position. So the cap is closed. Now this is where the dust collection device, which is sitting underneath, is now collecting any loose dust from the sample because it is connected to the vacuum chamber. So it's now collecting the loose dust. And let me show the status screen. And you can see the status of the instrument right now. So the loading position is solid. That means the sample is still in the loading position. The measuring position is empty. So in a few seconds, the sample will change over to the measuring position. Obviously, you cannot see that here, but from the status of this, you can make out that the conditions are changing. You can see all the dynamic parameters here. You can see the vacuum, the cabinet temperature, the water flow, and so on. So now the sample has moved. You can see now the loading position is empty, measuring position is solid. So now the sample is sitting in the measuring position and the measurement has started. So the status window shows the measuring has started. You can see the barcode, sorry, the bar on the top, the horizontal bar keeps moving, and you can see that the intensities are getting collected. Yeah. On the sample changes screen, once the measurement is finished, you will see the results show up on the left-hand side. Also, you can see here that currently this sample is being measured, so it is blinking yellow, and it also shows from which sample cup it is being measured. Now, let me show something interesting. What we also have here is what's called as a priority sample position. What this is if the customer or operator comes running with a priority sample. So there is a batch is running, and I'm going to now say, oh, this sample is priority, and I put it in a priority position. And on the software screen, you can actually see that a screen pops up, and you can now choose, or the operator selects the program, puts the sample ID, and he can decide whether to measure this sample next, or even if it's even more urgent, about the ongoing measurement, and then start this measurement. So let's do this. Let's say measure the sample next, and then I'm going to say measure. Okay. So let me close the lid because the sample has to be unloaded. And you already see here that the next sample is ready. It's waiting for measurement. So if you have a batch with hundreds of samples, you can see the result has already come out. So this means that the sample is being unloaded. You can see the status. So the measuring position is empty. So the sample moved, it's in the loading position. And now you can see the video, the cup is being picked up. And now the sample is being picked up by the suction. It moves it back to the same position. And it's going to now go and pick up the priority sample automatically and start the measurement. So if you are having a batch of 100 samples, and now you have to run a priority sample while the main batch is running, you can quickly come and put it on the priority position, and it starts the measurement after the current running sample. Okay. So,
okay, Hari, just explain just few minutes. Bapak-Ibu sekalian, di video tadi diperagakan oleh Mr. Hari. Jadi bagaimana sistem direct loading bekerja, dan di Zetium sebetulnya tidak membutuhkan sampel cup yang banyak. Jadi bisa menggunakan tray secara langsung. Nah, tray tersebut bisa ditaruh atau ditempatkan hasil prep, baik itu press maupun fuse. Nah, tadi sudah diperlihatkan bagaimana sistem apabila menggunakan sistem yang press. Jadi sampel langsung diangkut ke sampel cup, kemudian dianalisis. Namun hal demikian apabila misalnya kita sedang menganalisis 100 sampel, kemudian ada urgent sampel yang berbeda aplikasi ataupun yang sama, nanti tadi disebutkan ada priority sample. Jadi bisa interrupt sample ataupun bisa yang tadi bisa di abort dulu, lalu yang priority dilanjutkan, itu bergantung dari option. Jadi kita memiliki ada yang disebut dengan priority sample. Jadi untuk interrupt sample, untuk urgent sample seperti itu. Okay, Hari.
Okay, so this sample is currently being measured. So maybe in a few minutes, the result will come out and the sample will get unloaded. I might just quickly show the application windows just of interest, and then we can close it. So this is how the application windows look like. Now, if you are already a user of the Axios XRF, you might find that these are now slightly different looking windows, and they are much more user friendly. So let me show the nickel application that was set up. So these are the channels that were set up. These are the optics measurement conditions. You can see the crystals that have been collected, the collimators, the detector. In this case, we have simply used only one detector, the flow detector, and the measurement angle. And then what we have normally do is calibrate each element. So you can see the sensitivity calibration for each element. So we run a sample, check where the peak is, and then we also then try to calculate the sensitivity and the precision based on a simple calculation. So in this example, as you can see, measurement of chrome, this sample has about 0.9% chrome. So we run a scan, and then for this percentage, we calculate how many seconds you need to measure in order to get a certain detection limit. So the example here says, if you measure the peak for 6 seconds, background for 2 seconds, the detection limit is about 20 ppm, and the standard deviation error is 0.002. So it makes it very easy and simple to calculate the sensitivity, the standard deviation error, just by running a typical sample and doing this sort of calculation. So at the end, we will then have the total measurement time, as you can see at the bottom here, for all the elements. So this is the individual measurement time for the elements. The total time, as you can see, is less than 90 seconds. Yeah. Now let's look at the calibration screens. I won't go spend too much time there. So these are the standards that we use, and just to give you an overview of the calibration screen. So you can see how nicely the calibration of pressed powders has come out for this nickel ore analysis. So you can actually see that for iron, that's your nickel, and the accuracy or the RMS is basically shown in that table there. Yeah. And results can be obtained in a bulk, in a bunch, as you can see here. Now, if you're used to the Axios platform, then these are very, very similar. So it's very similar platform as the Axios. Okay, I think probably I might stop the session here. I might open for questions because we are almost.
Yeah. Yes, Harry, I see that we do have some questions from our audience. Let me go with just a couple. So what you mentioned regarding the add-ons, just want to check whether they're compatible with Axios and older models.
Yes, they are. Some of them are, not all of them. So the ED core is not compatible. The ED core is for the Zetium. The detectors that I showed, maybe I can quickly go and so the ED core is only for the Zetium. You can fit a barcode reader if you like. You can also have a fixed channel on the Axios. You can install a duplex detector. I believe the hypersync detector also can be installed. Some of the special crystals can also be installed on the Axios system. Yes, you can, except the ED core. Yeah, you can do the others. It depends on the age of the Axios, because Axios also have, from Axios to Axios Max, it has been different upgrades. So you'll have to check whether it's an Axios Max or it's the old generation Axios.
All right, that's a good tip. Thanks for that. Just a question about the press pellet method. So do you recommend if we're using the press powder method without the cellulose binder?
I would normally not recommend to prepare the pellets without the cellulose binder, and this is probably the main reason why you are having trouble making press pellets, and also the reason that you will have breakage and the samples falling inside the system, especially for mineral samples or ore samples. The best practice is to have a small amount of binder so that you get a nice and solid pellet. Now, it's a very simple technique to prepare this. All you need to do is just take 8 or 10 grams of sample with 1 or 2 grams of cellulose binder. Now, these are cellulose binders which are very cheap. They can available in the market. Put it in a vial, give it a nice shake, or if you want to, you can use a small vibrator. Take it, put it in the press it. Probably takes less than 5 minutes to prepare the samples. So I would strongly recommend to have the cellulose binder in your preparation.
Yeah, so that's all towards better accuracy and also repeatability. Let's see if we have more questions. I know that, yeah, this event is predominantly for the Indonesian market, but we are also conducting it in English for our other friends from the region. So just bear with us if you do see some questions coming in from Bahasa Indonesia. I do see some questions coming in, and maybe Hartoyo or Isan can help me out with the local language questions.
Yeah, one more questions coming from customer, and she asked about what is the meaning of the spectra element and spectra plus applicant.
Can you repeat that question?
Yeah, the question, what is the meaning of spectra element and spectra plus applicant?
Not very sure. We don't have anything called spectra element and spectra applicant. Where is that info coming from? Is it related to the Zetium?
Wait a minute, I will ask.
All right, guys, in the meantime, if you do have more questions, do pop them over in the chat. I do have a question that is asking about the time to run a sample, because that also impacts on the throughput analysis.
Okay, so this example which I showed, we had done this typical application for 90 seconds analytical time. Of course, there will be some overhead times to load the sample, unload the sample, and things. You probably could add another minute to that for loading, unloading, moving the optics, and all that for a typical application like this. So in say about 2 to 2.5 minutes, you're able to basically have a turnaround of measurement. So this is only one example. Of course, if you're doing many elements, so this is only a 9-element suite, but if you're doing more than 9 elements, if you're doing trace elements, then the analytical time is going to increase. So that's what I had shown in my first slide from a throughput point, taking into some of the overheads on this slide here. You are able to achieve, say, a 14-element suite, say 200 to 300 samples on a press powder on a 1 kilowatt system. If it's a 4 kilowatt system, then you can go up to 400, 500 samples, or even slightly more.
So if you would like to have your samples analyzed or looked at, we are collecting your feedback on this. And if you could help us to complete that information over on the survey, I know that some of you have already indicated interest to get your samples analyzed because you're interested to see what kind of data quality and speed. So I'm just going to put this in the chat right now. If you would like more information and also want to stand a chance to win a prize for the lucky winner who completes the survey form, this is the URL, and I'm just popping it into the chat right now. There are more questions coming in. Let's just take 2 more before we go on to our next demo session, which is on the benchtop XRF Epsilon 4, which I've noted many of you are interested in. Okay, this is a question for Hari. Talking about calibrations, how long can the calibrations be used on the Zetium?
The calibrations can actually be used for quite a long time. I mean, these are not like other analytical techniques like ICP, where you have to do a recalibration every day. I've seen customers have not done a recalibration for few years, let's put it that way. Now, usually for WDXRF, there will also be what's called as the instrument drift monitor setup, and the drift monitor will keep updating the intensity on a daily basis, and you don't really have to then touch your calibration unless you are changing the sample preparation methodology and things like that. Then you may have to look at doing a recalibration, but otherwise calibrations don't have to be done so often.
Okay. Hartoyo, is there anything that you need to translate?
Yes, this is one more questions. Hari, one of our customers, they turn off the machines on the weekend. Let's say in Friday, then in Monday, turn on again. But sometimes they got the problem with the stability is not good, and the result is not acceptable.
Yeah. Okay. So this
is that any impact with the machine? That's the first question. And the second question is there any sample verification to check the instrument stability?
Okay. Yeah. Let me address both the questions one by one. Now, first of all, if you're talking of the instrument like a Zetium WDXRF, we would strongly advise not to turn off your machine so often. I mean, every weekend turning off is fine. You may think that you're conserving power, but what you're then compromising is, of course, the stability of the instrument, because when you turn it off and it's off for 2 days and you're turning it on, you really have to wait for the instrument to stabilize, and that takes several hours. So you cannot switch on the machine on Monday morning and then start measuring samples within half an hour.
Sorry, Hari, how many hours for the sample? Let's say they turn on at 8 a.m. in the morning, then the sample, what time?
If, as I said, if it is a system like an Axios or Zetium, it is going to take at least 3 or 4 hours before you're going to have a reasonable stability. Now, what you have, what you have to look at is, if I can, maybe I don't know if the sample. If you're seeing my screen here, so look at these parameters. These are dynamic parameters like your cabinet temperature, vacuum, water temperature, and so on. Now, these are all things which will affect some of the optics inside, especially the crystals and so on. So these things take time to stabilize. So until these things stabilize to their normal condition, running any sample is going to give you variation. So this is one aspect. The second aspect is switching off your X-ray tube and leaving it in cold also is not recommended. I would suggest that leave the system on, leave the tube on at a lower setting throughout the weekend, and then on Monday morning increase the setting, leave it for about half an hour, and then you can start using the machine. And you can be assured that the system will give you a quite stable result. Sorry, what was your second question? If you can repeat that.
If there are any sample standard to check the stability of the machine. Okay.
Now, it doesn't have to be a very specific sample. If you want us to supply, we can supply some monitor samples. But all you need is some sort of a QC sample, it should be a fused bead or at least a stable monitor type sample. Run the sample, say about 10 times, and then look at the standard deviation of the measurement. And I can give you a quick practical example. Just see my screen, and I can give you this example here. So if you're looking at my screen, assume that this sample is your QC sample. So run it, say 10 times. Here you already see that the sample has been run 15 times. And in SuperQ, in the software, there's a nice feature where you can turn on what's called a statistics and also this counting statistical error. So what you're basically now checking is the stability of the instrument. So the measurement standard deviation, which is called as this RMS relative percentage, you see this number here. So this is the standard deviation of the 15 measurements. And okay, maybe you should do that on the count rate. So let me just show this on the count rate. So select the raw count rates of your measurement, not the concentration, the raw count rates. And then you can see the theoretical standard deviation, which is called as the CST. Yeah, and yeah, okay. So this is a good example. So get the raw count rates of the measurement. Look at the measured standard deviation, which is this RMS relative, and the theoretical standard deviation, which is CST relative. Now, if the instrument is stable, then the RMS should be less than 2 times the CST number for each element. So you can easily compare that. So here you can see the example here. My CST is 0.3%, 2 times that is 0.6. Look at the RMS, it is 0.35, so it is less than 0.6. So the aluminum channel is stable. So do that for every channel. And if this passes, this criteria passes, then the instrument is stable. Okay.
All right, thanks so much, Harry and Hatoyo, for that explanation. And let's move along to our next part of the program. Save your questions for Harry. Do pop them over into the chat, and we will be able to still respond to you one-on-one. Okay, so now next speaker is Dale Parsonage, and he is our applications chemist. He's going to share a lot of information with you on the benchtop XRF. And I know that a lot of you who have already responded to the survey have indicated a high interest in this benchtop and portable system. So we've got Dale, who's live from Puff, and he's going to show us around. Go ahead, Dale.
Hi, everyone. So I'm here in the Perth Applications Laboratory with our Epsilon 4 unit. I've got it next to me. You see it's nice and compact. It's sitting on the bench top, doesn't take up a lot of space. It plugs into 240-volt power, so you don't need to have a dedicated power source. It's handy to have an uninterrupted power supply for it, but obviously you can have a battery that can keep it running for a longer time because of the much smaller draw that the instrument takes. I'll bring you in, give you a look inside the instrument. So this is the 10-position carousel that you can see here. These are quite handy as well because the carousel itself comes out. So that means you don't need to load your samples in the actual instrument. You can pull that out and place it in. And you can also have additional carousels which are fully interchangeable so that you can load up another tray of samples. In the back here, this is the sample spinner, which is probably a little bit dark. Just a second. And so on here is a small cog mechanism which engages with the sides of the sample cups, and that allows for the sample to be spun during the measurement, which helps to average out the counting of the sample. Okay. So underneath our sample tray, we have a reference plate which contains a sample that is analysed routinely, which helps to account for the drift. It also protects the optics from any material that might fall into it when the instrument's not being operated. And it also stops anyone being able to access the optics and any damage there, so it assists in protecting it. So the best thing about this unit, being that it operates in a normal atmosphere of air with an optional helium flushing for improved statistics, it means that it can handle any type of sample. And that's great because, you know, using the large sample mode, you can run core samples, individual rocks to see what they are and what they average out at. You can get your core bags themselves as they come in and place that over the large sample holder as well, and analyse core samples directly once they've been crushed and pulverised. As we go through, you can also measure directly on a loose powdered sample. So we've got some of our nickel samples here that are provided. And then from there, we can move up into our pressed pellets, which we've based all of our calibrations on here today, and then through to our fused beads. Got some nice examples of some lovely coloured fused beads there. And so as we step through these different sample types, we actually improve our precision and accuracy of measurement, and that's to do with several factors that include the flatness of the surface homogeneity, the sample homogeneity. And then as you move into fused beads, you start to remove things such as mineralogical effects. And so what we're looking for in a good pressed powder sample is a uniformity of particle size. And so that helps the pressed surface, what's presented to the X-rays, be as smooth and flat as possible. It also helps the sample to stick together, which is really beneficial, less to clean up. And I'm not sure if you can see it, but because most samples will press together, try and get this up nice and close to the camera. And you can see that that has quite a marbled effect, and that's due to the differences in the particle size of the individual components in there. Whereas on our nickel samples here, these are actually really fantastic samples. They're nice and small particle size, it's very consistent. And so that's given us a nice flat and smooth sample surface for our analysis. And so all these things will help improve our accuracy. It's also very important that we maintain our pressing equipment. So this is the plunger out of my press, and you can see it is polished to a mirror shine, and so that is kept in good condition. Okay, the instrument itself is really easy to operate. I'm just going to switch over and share my view. Just connecting through to the instrument. Now, I do apologise that the instrument comes out a little bit small due to the resolution of the other PC. So this is the user interface of the Epsilon 4, and you can see it's very simple and it's easy to use. So down on the right-hand side of the screen, I have our various methods have been set up because being a pressed pellet application, the saprolites and limonite samples are quite different in their mineralogies. They actually have to form two distinct calibrations. And I'll talk about that a bit more when I discuss and go through my presentation later. So in terms of a measurement to get started, it's simply just a matter of choosing which application you want to use. You can enter your sample name. If you're using catch weights, so here I've got an initial weight of 8 grams, that's 8 grams of sample, and a final weight of 10, so I'm using 2 grams of binder. So if you did want to have that improved accuracy around having catch weights rather than target weights, you can input that information. You can also select whether you would like to perform repeat samples. You'll see over here as well that I've got this measuring as a routine sample. That's because it's going to be a routine measurement. Whereas you can also have things such as check samples because there is inbuilt statistical process control within the software. And so that's how you can navigate between the two, whether you want to have your quality control samples separated from your routine samples and have all those measurements performed and the results contained within its instrument. So I've got my sample, it's as simple as pressing measure and selecting the position that we're measuring. So there was a small click, and that was the lid lock engaging, which is part of the integrated safety mechanism. So I can now not open the door while the measurement's in place. While it's running, if you wanted to see the status, you can click on the sample carousel, and that shows us that we're analysing sample 5, and it tells us what our measurements that are running. So this application was set up and optimised to run for 3 minutes, and that covers off on the light elements of magnesium, aluminium, silicon, as well as the targets of iron, nickel and cobalt, and the additional calcium and chrome trace elements. So it's quite a fast analysis, and it can deliver some very accurate results in a short period of time. I've got that measurement running in the background. I'll just set up and get my presentation ready.
And in the meantime, audience, I know that many of you who have responded to our live survey, you have indicated that you are facing some challenges pertaining to, your data accuracy and precision. You also wanted some information about calibration and reference materials. So, really stay tuned, because Dale's going to be talking a lot about the sample preparation and how that can really impact on your precision analysis. Earlier on, I believe Hari had also mentioned a lot about the calibration and reference materials. So in case you do want to get more info, Dale can share a little bit with you later on.
Yeah, sure. Okay, so we've got our sample running. I also forgot to mention that the Epsilon 4 is capable of measuring liquids, which is quite convenient, especially for process situations where you might want to have a look at intermediate products and have that flexibility to analyse things such as water samples, oils in-house, and things that you might need to send off to external sources for analysis. You can bring on board with the Epsilon 4. And that's part of the flexibility that it's got. It's got flexibility in the types of samples that can be analysed. It's also got flexibility in the type of applications that can be set up. Okay, so I talk about it being a simpler instrument, and this is the breakdown of the ED optics versus the WD optics. So on the left-hand side of the screen, we can see the ED setup, which is a simple X-ray source that excites a sample and responds to a detector. Whereas on the right-hand side with the WD, we have to travel through a collimator to an analysing crystal, which then heads forth to a detector. And so by having this simplicity of optics, we are also having far simpler mechanisms that work in the background, which means that there is less that can go wrong and less that needs to be maintained. So it becomes a cheaper instrument and a low-cost operating option. So I pulled out the sample carousel 4, and you can see that carousel here now on the screen. And this is those nice simple optics that sit just directly under the carousel. So we've got the exciting tube on the left that travels through a filter wheel, energizes the sample, and then a detector that receives the incoming X-rays. And then that travels forward through a multi-channel analyzer and delivers us our results. So the Epsilon 4 has come a long way as our ED technology has improved. And this system has now got a 15-watt tube, which is capable of delivering 50 kV and 3 milliamps. And these settings are flexible, which means that they can be optimized for the excitation of the specific samples. And also when you're looking at press powders with separate analytes such as saprolite and limonite with their different mineralogy, it means that you can have improved performance on your individual sample types because those conditions are optimized to the material rather than having a general purpose calibration that is trying to achieve everything. So that feature means that you can deliver more accurate and more precise results on the materials that you're analysing. It has a large detector area. My instrument has the SDD30, which is a quite a large detector. They can also come with the standard SDD10. And that larger collecting area means that there's more surface area for photons to be received at the detector, which allows for higher sensitivity. We also have the fast counting electronics, which means that there is a reduction in dead time and overall less detector saturation. And that detector saturation is an important concept because that's what limits the current that we can apply, the amount of energy that we can apply to the sample. And with our instrument, we can achieve up to 1.5 million counts per second. It also has some excellent software, and that allows for a very advanced deconvolution. The deconvolution is when you look at a spectra and you're trying to resolve the entire area underneath the spectra, rather than looking at WD where you're looking at peak height. And so obviously there's some complex mathematics that is involved in deconvoluting an entire spectra, and our software is very adaptive and it's able to deliver a fantastic result. Should I pause there for translation?
Yes, there, please. Ya, Bapak Ibu sekalian, jadi ini adalah Epsilon 4 versi upgrade version, jadi memang berbeda yang saat ini digunakan di pertambangan nikel. Jadi ini yang tipe 15 watt. Jadi power 15 watt ini bisa digunakan pada 50 kP dan 3 mA. Jadi ini bisa disetting fleksibel sesuai dengan kebutuhan. Ini sangat penting terutama untuk analisa light element. Selain itu di tipe Epsilon 4 15 watt ini detektor areanya lebih luas, jadi ini ada 30 mm diameternya, 30 mm ya 30. Sedangkan untuk yang versi Epsilon 14 itu 10 mm, jadi 3 kali lipat. Ini collectingnya menjadi lebih banyak ya, lebih tinggi menangkap fotonnya, informasi dari sampel. Selain itu juga ini fast counting elektronik, saya kira ini adalah benchtop system yang tertinggi untuk kemampuan detektornya. Jadi di EDXRF kemampuan detektor sangat menentukan untuk menentukan performan dari XRF itu sendiri. Ya, selain software yang memang sudah mature ya, ini dekonvolusi sangat membantu untuk akurat analisa. Dan secara optikal ini adalah cross coupling. Jadi cross coupling itu sangat berdekatan antara X-ray tube, sampel dan detektor, sehingga memastikan sensitivitasnya adalah sangat-sangat tinggi ya. Ini terbukti performa dari Epsilon 4 ini sangat cocok untuk di berbagai sampel, termasuk bisa untuk liquid, powder maupun press dan juga fusion. Yeah, I back to you, Del, please.
Okay. And so I talked a lot about technology and how it's improved in the last 10 years or so, and this is the improved counts that we can see between our Epsilon 3 XLE and our Epsilon 4, and that's to do with that detector and the higher counts that it can achieve, the lower dead time. So overall, when we energize a sample, we can get a much larger signal, and obviously when you're receiving a much larger signal, the statistics are better, the accuracy is better, and the sensitivity is better. Okay, so as I said, it's easy to use, it's got flexibility.
Bel, could you please back to the previous slide on the competition? Ya, Bapak Ibu, jadi ini ada perbandingan Epsilon 3 dan Epsilon 4. Jadi kalau kita lihat di sini perbandingannya sangat jauh berbeda ya. Ini salah satunya juga adalah karena kemampuan detektor yang dulu Epsilon 3 itu 200 CPS, sedangkan Epsilon 4 ini 1,5 juta CPS. Jadi ya ini impact-nya sangat berpengaruh kepada intensitas yang ditangkap oleh detektor itu sendiri. Ya, back Del, can you continue? You can continue.
Okay. So yeah, so the instrument's very easy to use. It's nice and simple. So in terms of your sample entry, you can choose your sample type, select your method. I showed you through that. There is flexibility in the languages that the software displays. So it's just a matter of pressing measure, inputting your data, signaling the location of the sample, and your results will be displayed on screen. So to measure all sample types, you can see here we have a mobile phone placed over the optics. That was that large sample mode that I talked about because the tray is removable. And so you can put a variety of different materials simply on that large sample spot. It has a sample spinner, which improves accuracy. So I showed that example of a pressed pellet that had a heterogeneous composition. And so by rotating that sample, you're allowing to produce better averages of the results and get a better idea of the actual makeup of the sample. We can measure lots of different sample types from our solids, whether they're in a powdered form or presented as a solid. You can measure liquids, and you can also measure air filters, which is quite popular in the pollution monitoring and control space. We also have the option for helium as a purging medium for light element analysis. And essentially, because of the energies involved in the light elements, they are attenuated by the atmosphere between the sample and the X-ray, and the sample and the detector. And so by introducing a light noble gas such as helium, which has a lower density, it attenuates the sample from the signal from the sample less, and so you're getting more of a response to your detector. And so that improvement can be seen all the way from measuring carbon to calcium, and the switching time between helium and air is quite low, so it doesn't add a lot to your analysis time. But it also doesn't use a lot of helium. It's got quite a low flow rate, and the helium is only turned on for measuring the conditions that require helium. And so you're not using a lot. It's not a high additional cost to your analysis, because you can get up to 500 samples or 500 analyses per helium bottle that's used. But what you can see as a result of that is that you're getting a better response from those light elements to the detector. And obviously that will improve your results in terms of your sensitivity and your accuracy.
Ya, Bapak Ibu. Ya, Bapak Ibu, bahwa Epsilon sudah standar ada opsi untuk menggunakan helium ya. Jadi Bapak Ibu pada saat membutuhkan improve memperbaiki performa analisa light element, ini bisa menggunakan helium, dan penggunaan helium ini tidak juga menjadi biaya yang mahal karena penggunaannya sangat hemat ya, hanya setengah liter per menit, atau kalau dihitung 5.000 analisa untuk per botol helium. Jadi ya, ini opsi yang bisa gunakan Ibu untuk analisa, untuk memperbaiki analisa light element. Ya, Del, please.
Okay. The instrument also comes with internal drift correction. So the reference plate that covers the optics has a alloy in it, and the instrument will automatically measure that and return the counts and then correct for any drift. Because drift is a function of an X-ray tube in its life cycle, that it will, over time, it will degrade and it will deliver less counts. And so by measuring this drift sample routinely, daily, it can look at the tube drift and then correct the results based on how the tube has changed on a day-by-day basis. And that function means that you can remove the need for timely and expensive recalibration exercises on a weekly basis. It also has correction for environmental variations. Obviously, in an ideal situation, such as my laboratory here, we've got temperature control, it's nice and stable. But that's not necessarily the case when you're out in the real world and it's out in a plant or even at a site. And so there is additional temperature and air pressure sensors within the instrument that are monitored, and then corrections are made within the software to help minimize this drift. And also mentioned that so there's no need to run in a vacuum atmosphere such as with the WD, but you don't have to have the helium. It's nice to have, but if you're not focused on sodium and magnesium and you are looking at more of a heavier suite, then it is fine to operate just in air as it would normally.
Ya, oke deh. Bapak Ibu, jadi di dalam Epsilon itu ada internal drip correction. Jadi internal drip correction ini sangat-sangat membantu untuk menjaga stabilitas analisa Bapak Ibu dari hari ke hari, bahkan bisa bertahan dalam waktu bulanan. Jadi tidak perlu melakukan rekalibrasi, weekly kalibrasi untuk aplikasinya. Karena di dalam sudah ada internal dan environmental correction, jadi ada perubahan suhu, ada pressure, itu bisa dikoreksi dengan internal drip correction. Dan juga perangkat ini tidak harus menggunakan vakum, sehingga memang sangat mudah mengoperasikannya. Ya, back to you.
Okay. So the application strategy is also flexible as the different sample types that are. And so when we look at our applications, we can choose to calibrate the instrument in a variety of methods. And so we have our conventional calibrations where we take a series of known standards and we look at the X-ray intensity and we plot the intensity versus the concentration, and then we use that to calculate our concentration of our routine samples. We do also have a standardless analysis program, which is able to be calibrated on the Epsilon 4. It's called standardless, but it is initially calibrated with a set of standards. However, within the software, it allows for it to have flexibility and also interpolate certain other elements based on the intensities of the known standards. And by doing that, you can deliver the periodic table from fluorine to uranium after one calibration. Now, the standardless isn't as accurate as a fundamental calibration. However, it is great for when you have some samples that you might want to have a good idea of what's in them, but also in a process control situation where you perhaps have some process outliers or looking more at stability rather than accurate results. Now, Harry touched over the...
Okay. Yeah, you can continue. Combined with this information. Continue. Okay.
That's okay. Now, Harry touched over our Roxy package. This is something that can also go on the Epsilon 4, which is a great option when you need to source your standards, because it all comes in as a distinct package, and that delivers a wide variety of common elements off the periodic table. They do have to be fused, Harry mentioned that, but by fusing we remove our mineralogical effects, the particle size effects, and those surface roughness effects. So while there's some complexity involved in going down fusion as a sample preparation technique, if you want accurate and precise results, it is the best way forward.
Yeah, Del, can I expand to Omnian first?
Omnian first?
Omnian, ya, oke. Ya, Bapak Ibu, Epsilon juga bisa dikembangkan dengan dua teknik kalibrasi ya. Jadi bisa dengan konvensional kalibrasi, artinya dengan membandingkan CRM, dan juga bisa standardless analysis, jadi dengan tanpa menggunakan standar. Fungsi dari standar analysis ini adalah untuk mengkalibrasi sampel-sampel yang unknown, yang susah mencari standarnya. Kalau misalnya Bapak Ibu dapatkan sampel yang solid, liquid ataupun metal yang tidak ada standarnya. Ini bisa menggunakan teknik standarless dengan Omnian. Ya, ini adalah boleh katakan semi kuantitatif, tapi hasilnya mendekati konvensional kalibrasi. Ini bisa dikembangkan untuk Bapak Ibu untuk menganalisa non sampel. Ya, next please. Next slide. Ya. Dan juga selain di Zetium sebelumnya diterangkan, Roxy juga bisa diterapkan atau digunakan di Epsilon ya. Jadi Bapak Ibu bisa mengembangkan analisa mineral yang lebih luas dengan menggunakan Roxy sebagai acuan utama atau reference standarnya. Dan dari reference standar ini, Roxy ini bisa diturunkan membuat in-house standar ya, dalam bentuk apa itu press ataupun fuse. Ya, tapi syaratnya memang Bapak Ibu harus mempunyai perangkat fusion mesin minimal yang satu posisi untuk membuat sampel standar dan bentuk fuse. Ya, Del, you can continue.
Yep. And so there's just an example of the Roxy standards versus CRMs, and with the fuse bead preparation, how you can achieve wide-ranging calibrations. I mentioned it before, talking about the different sample types and the nickel ores that we have here, that there is need for multiple applications, multiple calibrations. And this is a very good visual for why that occurs. And so you can see here an example of silica that is in some certified reference materials. And when they're presented as pressed pellets in calibration, you can see on the screen on the top left that they almost follow three distinct calibration pots. So that's where with our saprolites and our limonites, we would need to have separate calibrations because of that effect. Whereas when you look at fused bead presentations, because you're removing those mineralogical effects, and that's the right-hand side of screen, you can see that the CRMs all line up and form a very good calibration from 0 to 100%. I'll stop there before I go into the results. If you wanted to translate.
Ya, Bapak Ibu, jadi ini perbandingan kalibrasi dengan fuse and press. Jadi bisa kita lihat bahwa dengan press itu matrik impact sangat mempengaruhi. Jadi ada beberapa, misalnya di sini pada press pellet maupun dengan CRM tetap akan berbeda trennya, sehingga ada kemungkinan harus membuat beberapa kalibrasi sesuai dengan matriknya. Nah, dalam hal ini limonite dan saprolite ini memang dianjurkan apabila mengepreparasi press pellet itu menggunakan kalibrasi aplikasi kalibrasi yang berbeda. Nah, apabila kita menggunakan fuse ini tidak terjadi ya, tidak terjadi perbedaan, sehingga kalau kita lihat garis di sini linear ya, dari kadar rendah sampai dengan kadar tinggi. Ya,
Yep.
Del.
Okay, so moving on to the application study. And so we had our nickel laterite ore samples that were a mixture of limonites and saprolites, and that's just showing the difference between the two materials. They are quite different. The limonites are higher in iron, whereas the saprolites are much higher in magnesium, and have a narrower range for the silica present. So from this material, I set up a calibration and application for the two types. For the limonite material, which has a lower magnesium concentration, I set it up both with and without the helium, and I'll discuss the different implications on precision and accuracy. So here we're looking at the limonite calibration plots for both nickel and iron. And so you can see that by using pressed pellets, we can get quite an accurate linear plot. However, there is a small amount of deviation both above and below. We have a certain amount of error involved, and that can quite often be present in pressed pellet applications because of the factors that you can't control, such as particle size and surface presentation, and the difference in sample preparation from one to another. A certain amount of this can be removed by preparing duplicate standards. It can also be corrected for by having a larger amount of standards that are used in the calibration. So obviously when you can cover the calibration range in more detail, you can get a better result for your analysis. Moving on to the light elements, you can see these are actually quite good graphs, especially on the aluminium and the magnesium. But this is using helium, which does help to correct for the issues with light element analysis. So looking at precision and accuracy, took one sample from each and performed 10 repeat measurements. And so you can see across the various analytes, the standard deviations that were achieved across 10 repeat measurements, which is an excellent indication of the precision of the measurement. You can also look at the variation to the target value and then that variation as a relative number. And you can see that the overall variations are very low, which is indicating that the analysis was very capable of producing an accurate result. Now, I mentioned improving precision with the helium measurement. So this is looking at a distinct calibration using only limonite samples, both with and without helium. And in the graph below, we have the magnesium calibration plot, which magnesium is the most affected out of this suite by the analysis atmosphere. And so what you can see is that with using the helium, we're able to produce a more accurate result. We produce lower standard deviations and overall lower variation in our results. And this is just to show that as you move along the light elements, as we start to get a larger Z number, we see less improvement by having helium. So with aluminium, it's still, and silica, it will still give us a better result, but it's not as pronounced as the effects as seen with magnesium. And this is those same types of samples, but presented as fused beads and a much faster analysis. So the fused bead analysis can also be done on the Epsilon. And this, we now get into having one calibration, and it's a slightly longer analytical time because in this one we're actually looking at some trace elements as well that are present. Again, mentioned that there's no absolute need for helium, unless of course you are trying to improve that accuracy around magnesium itself, which can be a bit of a benefit with fused beads, in that you are going to get improved results on your light elements, and so you're already getting advantages and benefits in your analysis. And this is just comparing that calibration accuracy with fused beads, both with and without helium. And so, as I said, you don't have to have the helium there, but you can get better results when it's present. Was there anything you wanted to go back and cover with that?
Ya, Bapak Ibu di presentasi ini mengambil contoh setrolit dan limonit, di mana untuk light elemen seperti magnesium, silika itu di sini rekomendasikan, dan aluminium juga dikombinasikan menggunakan helium. sehingga performanya menjadi lebih baik. Nah, di sini memang contohnya lebih lama yang biasa dilakukan, yaitu 9 menit, karena memang di sini mengejar limit deteksi, ada beberapa yang limit deteksinya rendah untuk beberapa elemen. Ya, Del, you can continue.
Okay. And so overall, the Epsilon 4 it's a nice compact unit. It's got very flexible applications and types of samples that it can use. It's easy to use. Its simplicity of design means that it has a lower cost of ownership because it has reduced maintenance requirements. There's a wide variety of calibration strategies that can be used on it, even with its simple design. So it can still use Omnian calibrations, wide range calibrations such as Roxy. And you can improve the precision of your results by employing optional helium purging. Okay. So we've got our results on the screen. Oh, sorry, I've got the wrong display up. Bear with me. So the analysis didn't take as long as my presentation did. It was over and done quite quickly in the first 90 seconds, and we've now on the right-hand side of the screen, our result is available. Another great feature with the Epsilon software is an automatic program selection. So we mentioned how the saprolite and limonite have to have separate applications to run in order to get the best results. You can introduce a third program, which is an automatic selection program. And with these materials that are quite different, you could have it to look at only iron and magnesium and essentially run for a very short period of time. And so you present your sample into a location, you select the automatic program selection application. It will quickly scan the iron and magnesium, and then based on those results, just on the count rates that are there in the sample, it will choose automatically whether it needs to run the saprolite program or the limonite program, which is a great feature because it can take the guesswork out of your samples to know which is the best program to analyze them on when they've been processed through the laboratory.
Oke, I interrupt. Ya, Bapak Ibu, bahwa di Epsilon 4 ini salah satu juga keuntungan ada fasilitas untuk automatic selection program. Jadi seperti tadi saya disampaikan bahwa untuk limonite dan soprolite disarankan untuk menggunakan aplikasi yang berbeda. Nah, dengan auto selection ini Bapak Ibu tidak perlu mengecek dulu ini apa saprolite atau limonite. Nah, nanti tinggal masukkan saja sampelnya, nanti akan automatic selection berdasarkan misalnya variabel apa yang ditentukan. Apakah high kadar dari besinya atau ironnya yang sebagai indikasi bahwa itu limonite atau soprolite. Nah, nanti automatic selection akan menentukan pakai kalibrasi yang mana yang sesuai. Yeah, back to you, Bel.
Okay, well, that was all I had to share with you today. Did you want to open it up for some questions?
Yes, thank you, Dale. I think I'm going to read out some questions from the audience now. So, okay, for you, Dale, I have, what is the general analysis time on the E4?
Well, it obviously varies depending on the type of application that you're looking at. For an ore sample such as this, where we've got targets of iron, nickel, and cobalt, which are transition elements that are closely positioned, and then light elements that are also closely positioned. The instrument only needs to run 3 condition sets, which means we can have a very short analytical time. So this program is running for only 90 seconds, and it can produce very accurate results. When you start to add things such as trace components in there, that can obviously increase the analytical time, because you need to analyze for a longer period to look to a lower level. So yes, it does depend on what you're looking at.
Okay, great. Just want to also direct the audience, on the screen we have the survey form QR code. So if you still haven't completed that, please go ahead and capture that and finish the survey before the end of the session. Okay, so another question we have for Dale. Is the system portable, and how easy is it to install?
That is a good question. So I suppose to a point the system's portable, as in you can move it from one laboratory to another laboratory. You want a stable location for it. But it is very easy to install. It runs on normal power. It has the only additional service is the helium if it's there, but even for my laboratory, mine sits on a small trolley, so that when I want to move it or take it to demonstrations, I can move my whole setup very quickly. It also warms up and stabilizes very quickly as well. So within moving it and having the instrument switched on, you can probably be analysing a sample within the first hour or so in a new location.
Okay, great. We have another question. For limonite samples, how long do you recommend the sample analysis for CO, Si, magnesium result in for accurate and precise results?
So for just cobalt, magnesium, and silica, that analysis time could probably be a little over 1 minute, maybe just under 2 minutes, if that was the only 3 things you were looking at.
Yeah. Okay, great.
Most of the counting time is spent on light elements because of the poor X-ray fluorescent yield, and it's hard to improve on that. It's just a function of the elements that you're analysing. And so if you were looking at an application that was only measuring iron, or even only iron and nickel, that could actually be achieved very quickly. You could have a result in under a minute.
Okay, thank you. We have another question here. So can the Roxy be set up on the Epsilon 4?
Yes, the Roxy package can be set up on the Epsilon 4. We have quite a good solution for that, and it delivers very accurate results.
Okay, great. Does helium always be required for analysis at all times?
No, the helium is only used in the condition sets that require it. And so if you're only running one light condition set to look at magnesium and aluminium, in this program that I've set up, that runs for 90 seconds. And so the helium is only operating while that one condition set is running. And then when it switches, it turns the helium off and the system flushes back with air, which helps to reduce the amount used. And as I said, you can get up to 5,000 analyses off one bottle.
Okay, thank you very much. I have a couple questions for Harry, and then I think we will start to close off the session. So Harry, just want to ask, if we do up to 200 samples per day and use press powder, which instrument would be recommended?
Okay, interesting one. So 200 samples on a press powder, as I showed in one of my slides, the Zetium 1 kilowatt can easily cater to that. In fact, I would say that even the Epsilon 4 can also cater to that workload if it's on test powders, because the analytical time is only like say 2 or 3 minutes. Now this also depends on the analytical suite. That means the number of elements being measured. So if you're doing a standard mineral analysis of say 10 to 12 elements, major and minor, either the Zetium 1 kilowatt or the Epsilon 4 should be able to cater to this. Of course, it will depend on the budget and things like that, but yeah.
Okay, thank you. Can we do liquid samples in the ZTM?
Yes, yes, definitely, yes. We can do liquid samples, even loose powders. The only thing required for that is to have the liquid sample flushing attachment. So the standard ZTM works under a vacuum atmosphere inside. So you just have to have, say, change over to a helium atmosphere, and that's an accessory that can be purchased with the instrument or even a bit later. Yes, you can do liquids.
Okay, great. And does MP provide certificate analysis for our samples?
Yes, we can definitely provide certificate analysis. So in one of my slides, or even earlier, I think Mel was mentioning, if you remember, we do have our certifying lab in Nottingham in UK, and they will be able to analyze customer samples and provide certificate analysis. They primarily use the Roxy-based analysis. So any oxides, any silicate-based materials, we can actually do the certificate analysis. So if you're from a bauxite industry or even nickel ore industry or cement, and if you want to develop secondary standards, then you can collect samples and send it to us, and we can get them certified.
And maybe this is a question, whether we do have some time or not. If Dale, you could show the Omnian. Otherwise, we can, if it's not convenient, we could always arrange for another session. Not to worry. Let us know.
I can very briefly go through it. No, I'll just allow me to switch over the screens again.
And audience, for those of you who are not familiar with Omnian, it is a standardless package, so it's great for unknown samples. And just to clarify, if you're looking at mineral samples, you want to look into Roxy, which is spelled as WROXI. So it stands for wide range of oxide and other minerals. So yeah, you can see on Dale's screen, we have the Omnian software that is installed on the right-hand side.
Okay, there we go. Oh, my cursor, I'll have to operate from here. That's okay. So the Omnian is, as I say, we call it a standardless program because the standards are a fundamental calibration. It is an additional module and license, and so it's actually operated through the dashboard here in terms of its setup, but it still measures from within the normal software, which means the analysis is right at your fingertips. Again, it's the same. I actually have my Omnian set up to run in both helium and in air environments, which has that flexibility for customers that might not opt to have the optional helium, but you can run the Omnian both with and without. The Omnian requires the input of information to help it resolve some of the differences, because this being a standardless calibration, which is done on a mixture of fused beads and pressed pellets, but it can be used to measure anything from liquids to solids to powders, papers, air filters, anything really that you can put in it, and it will give you a reasonably accurate result. However, in order to resolve that, you need to provide it with some additional information. So here we can see that we not only identify our sample, but we can put in whether we're analysing a fused bead, or we can analyse loose powders and pressed pellets, liquids. And depending on what we choose, we then need to add in some information such as the weight of the sample, the thickness, the height of it, the density, and that helps the software to resolve and give us a more accurate result. And so the analysis time is a little bit longer for Omnian, because we're scanning across the entire periodic table. It's not about delivering a fast result, it's about using the best of the instrument to deliver us a semi-quantitative analysis outside of what you're normally calibrated for. And again, as I say, that's really handy when you've got something that's changed in your process and you might want to be able to have a look at it. You can run it through Omnian and you can see that perhaps the ore body's changed, or something might have changed within a flotation system. And it helps to resolve some of those issues. So within the results, so this is some pressed pellets that will run. It delivers us our result in terms of concentration. We can also take a look at the spectra. And by looking at the spectra, you can actually see what is present. You can turn on and off elements, because with EDXRF, it's a fundamental, when you have both alpha energies and beta energies present, it identifies the material. So you can really scrutinize the periodic table and help to see whether the Omnian has given it an accurate result, and also look to see when there is unresolved peaks and have additional information added to it. So if I wanted to toggle on and off elements, it's as simple as selecting them within the periodic table and then applying that to the calibration. And you can look to see whether these additional materials are present. The hotkeys don't work as well when you're operating through a remote viewing software. Have to remember to click instead of doing it. So you can see that we've got this unidentified peak here at 17.7 keV, but you'll notice that there is a coloured deconvolution underneath it. And so while that is close to the molybdenum K energies, the peak isn't actually present at molybdenum K alpha or at K beta. And so this would be an artifact of something else, perhaps a doublet peak of a high energy major that was present in the sample. And so by applying that information, you can really hone in the Omnian analysis and get it to deliver the most for you. Okay, Mel?
All right, thank you so much for that demonstration, Dale. And I do see quite a lot of questions coming in, wanting to see obviously more demonstration, whether it's on other kind of samples, petroleum and so on. So let's save that for another time, because we do have other sessions that can, showcase about, these samples. And also I've been noting down quite a lot of the questions and also survey feedback pertaining to wanting to know more about how to manage the calibration as well as reference materials. So we'll take that into account and we'll plan something for the future and let everybody know. Just want to let you guys have a last chance to complete the survey, and my colleague Samantha or Hanif, if you could just drop in the survey link. We're going to announce the 5 lucky winners of people who completed the survey. So just quickly do that right now and you can stand a chance. So just going back to the questions so far, Sam, I think we do have time for, say, 3 more questions before we wrap up.
Yeah, definitely. Let me just go and have a look at some more questions that we have. Okay. What services needed for the 1 kilowatt ZTM operation? So this one will be for Harry.
The 1 kilowatt ZTM does not, to start off with, does not need
Oh, hang on, Harry. You are muted right now. So can you unmute yourself? Yes, now you're fine. Okay.
Okay. Yeah, so the 1 kilowatt ZTM, there is a bit of echo, I think. Yours there?
Yes, I've just muted Dale.
So the 1 kilowatt ZTM, at least as a starter, does not need an external water chiller, unlike general high-powered WDXRF. But it, of course, needs the P10 gas for the flow detector, your normal power supply, and compressed line for the compressed air. So the installation is, I would say, reasonably simpler and easier compared to having a high-powered XRF with an external water chiller connections and things like that.
And then there's a question, Harry, that's pertaining to, I think it's the UPS or the power source. So this is a question of, should we use a UPS for the Zetium? Because we use the generator for supplying the electricity here.
Yes, we would highly recommend that a UPS is used, because these are analytical equipment with sensitive electronics built in. So a clean power is advised, and yeah, hence a UPS would be recommended.
All right. Let's see if we have time for one last question. Is there an easy way to calibrate the Epsilon 4?
Okay, yeah, the Epsilon 4 in general is quite simple and easy to calibrate. In fact, we normally supply a wall chart or an easy reference chart with screenshots and procedures. So in my opinion, anybody who just is able to read that can easily set up the calibration. And a typical calibration does not really take that long. Probably in 1 or 2 hours, you should be able to just set up a calibration. The only thing that might take time is depending on the number of calibration samples, the measurement time of the samples. So if you are going to have 50 samples in the calibration, then it will just take that long to measure the samples. But the setup itself is very simple and quick, and the software is quite intuitive as well.
This one is a question pertaining to how do we use monitor samples? We currently have it, but we don't know how to use it.
Okay, that's actually a good question, an interesting one. So the whole purpose of a monitor sample is to do an instrument drift correction. So what does that mean? So the instrument, let's say if you're talking of the Zetium or any WDXRF, so there are a lot of dynamic parameters inside, you know, like temperature, vacuum, water flow, cabinet temperature, and so on. They keep changing, and they all have an influence on the X-ray intensity coming from the sample on a day-to-day basis. So a monitor sample is used, and this monitor sample needs to be a very stable sample, not a pressed powder or a loose powder. It has to be a glass bead or a metal. And when you set up a calibration, you measure this sample for the elements of interest, and it registers the count rates of those elements. on the day of the calibration. And then you measure this monitor every day, and it collects the count rate on that particular day. It then compares with the original count rate on the calibration day. It calculates a ratio and uses that ratio and corrects the raw count rate of your routine samples. So if you're running routine samples down the line in, say, 6 months or even after a few days, there could be small variations in the count rate, and the monitor basically corrects the count rate and makes it as if the routine sample, if it was run on the day of the calibration, what the count rate will be. So this way, your results accuracy is ensured by running the monitor sample. Now you can decide on the frequency of running your monitor. Many customers run the monitor every day in the morning. Some customers, I see, they run it once in a week. If the machine is running round the clock without switching off, then the monitor can be run say once in 2 or 3 days or once in a week, things like that. But a good lab practice would be to run it once every day. Now, if you are having a monitor and you have not using it, maybe it's a good time to check with our service guys on how to set that up. However, just a caution that you cannot set up the monitor first time after, say, several days after the calibration. So the monitor needs to be set up when the calibration is being set up.
Okay, that's a really good tip, Hari. I think the audience definitely appreciates that. And just a last question, how do I detect carbon and high carbon ferrochrome using the Epsilon 4?
Okay, we can measure carbon on the Epsilon 4. We have a special version of the Epsilon 4 with a special detector. It's called as the ultra detector, which can measure carbon. So the standard Epsilon 4 starts from fluorine, but if you really want to measure carbon, then there's a special detector, and you need to buy that version of the Epsilon 4, which is sensitive to measure carbon. But again, it depends on how much carbon you are measuring. Obviously, we are not talking ppm levels of carbon. If it is percentage level, even lower percentage, then we should be able to measure that on the Epsilon 4 with this special ultra detector.
All right. I think that those are really good questions that came in, and we're really grateful for everybody's time and also, assistance in terms of participating in today's session. So if you do see my screen right now, I'm just sharing some final resources that you can go to really find out a lot more information. We have different solutions coming in, whether you're looking in at base metals with nickel and so on. I see in the survey feedback, a lot of you are looking in nickel. So do go onto our website, malvernpanalytical.com/mining, and you will be able to find out our total solutions on that. And we do have a lot of blogs that are written about mining, exploration, process monitoring, and QC, even a lot of tips pertaining to calibration and reference standards, all on this blog. So we will be sharing more information with you after the event is over. I did receive quite a few questions about whether the event is being recorded. Yes, it is. And if you think of more questions along the way, this is the email address that you can reach out to us at apr.info@malvernpanalytical.com. And so right now, I'm just going to announce the 5 lucky winners of our prize, and we have some limited edition Malvern Panalytical gifts sitting right now in the office and waiting to be received by 5 lucky people. So let me announce the names, and here they are. So If your name is on the screen, congratulations, and we thank you for your feedback and survey, and we will be contacting you shortly if you have been selected as a lucky winner. So these are all random, and the winners are picked at random, and it's just all in good fun and yeah, good fun effort. So with this, I wish to close off the session and thank you very much for joining. And if you do have more questions for us, we will stay online and we will respond to them one-on-one. All right. So thank you very much for your time and please take care and stay safe. It's signing off now. Bye-bye.
Oke, thank you. Ya, terima kasih.
Goodbye.
Terima
Kalian.
kasih. Bye-bye.
Berikutnya. Bye.